Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench I have a Harman Kardon HK440Vxi receiver. Now, this one I think came to me from eBay. I can't remember if I purchased it. I'm pretty sure it did. And I think I bought it as a parts unit only because it was so damn cheap. So here it is. I did give it a little bit of a test drive yesterday before the video. I wanted to get a little info on what it does or doesn't do. And the balance pot's really effed up. Like, I was using it yesterday and I had no right channel. Right channel was out and the left channel was out. Unless I wiggled the pot into a certain position, if I got it just right around the 8 o'clock position here, I could get sound out of the left side. And that was it. And yeah, no right channel. But I later figured out the right channel problem. The right channel problem is this thing here that does not hold a lead in. It's busted, so it just falls out, and they're both busted. I don't know how both of these got busted on the right channel. Well, that one there is holding a little bit, but we'll have to deal with that somehow. This is not a shelf queen for sure. It's pretty beat up, dirty. It's filthy dirty, and it has scratches, looks like right on the window, which is not cool. So yeah, pots and switches definitely, cleaning definitely. This volume pot here is really bent up. I don't know if you can see it, the wobble in that. So we'll try straightening that. Everything else looks okay. Let's see here, everything else looks okay, but yeah, it's filthy. Now I have a 550Vxi in my garage, and I love listening to that. It's quite a machine. So this is probably, well, this is the next step down from the 550. I think it just has a little bit less power, same features, but less power. The black face and everything. And like I said, the 550, I'm using it in my garage. Sounds great, rocks the neighborhood, and pisses off the neighbors. I try not to do that too much, but yeah. So it's digital tuner. It has the high voltage, high current selection on the back. You can select between 4 ohm speaker impedance or 8 ohm speaker impedance. And what this does is it sets up the power transformer for different voltages, different currents. So when you have it on 8 ohms, it sets it up for a higher voltage going into the power amplifiers. And when you switch it to 4 ohms, the voltage drops, but the current is higher, so it allows for driving 4 ohm speakers. I think you get basically the same power when you use the 8 ohm with 8 ohm and 4 ohm with 4 ohm speakers. You basically get the same power output because you're using the same transformer, and you can only get so much power through an iron core transformer for a certain size, right? But so let's turn this on, try it out. I'll demonstrate the balance pot, how it's messed up, and we'll take it from there. Alright, firing the hole, turning it on. 13, 14 watts. Amplifiers come on, jumps up to 26, 27, 28, 29, it's climbing. Alright. So we have it set up for a tone on CD. There is no phone. Oh, there is a phono stage on here. I didn't see that on the back. It says phono up front, but not on the back. I didn't see it. So here is a 440 hertz tone, right channel. There's the left channel. And like I said, you have to get it just so before it will work. But that does you no good when in the 12 o'clock position, because you have no left channel there. I think what's going on here is I got cracked solders on this balance pot because it's very touchy. Either that or the pot's damaged. This thing was shipped, so that explains the damage to the volume pot, and maybe this one took a hit too. So yeah, let's see if we can get some tuner action here. AM. It's absolutely silent. FM. Is there a muting? There's no muting. Oh, there's a little bit of hiss. Phono. A little bit of hiss. Okay, let's take the top off and have a look inside. Alright, the big reveal. Let's have a look at the lid. Yeah, that's kind of nasty. That's really nasty. There's some hair there that I don't want to touch. And dust. A little bit of smoke staining on the top there. But inside looks complete, untouched. It's pretty dusty back here along the amplifier, but I think a little compressed air will fix that. I know it pisses people off, but I'm going to do it anyway. Back here looks like we have a phono stage, discrete transistor, and it looks like they have a couple of voltage regulator transistors here. It's a D1266, and what's this one? A B. Yeah, so it's got a plus and minus regulator here at the back. I can see some Zeners and some transistors. This is all phono stage with its own little power supply. That's kind of cool. Right on top here we got tuner. Left hand side is power supply for the tuner, and then we have our tuner chips, LA1266, LA3410. What else is there? This is a logic chip. And then we have our tuner front end. It is very active tuning. It's all electronically controlled. Yeah. So underneath the tuner we have our main power supply, and we have our power amplifier. And I'm assuming up front here we have our tone amplifier underneath this here. Let's see what else we have. We have our speaker switch, little board, headphone, and here's our power. We have exposed wiring. We got exposed fuse, so we got to be careful of that. We can't touch that at all. And yeah, so we'll have to be aware of that. Cute little transformer, tiny little thing. I don't think this thing pushes much power, not at all. Yeah. Alright, the bottom is not removable. I'm going to unplug this. But there is some red plastic things rolling around in here. And this red plastic, I think, is coming from this speaker connector switch. Speaker connector here. So I don't know what I'm going to do about that. I don't know if I have a replacement for this or not. Or maybe we could figure out another solution. Yeah, maybe I'll figure out another solution. Don't know yet. Didn't test the tuner, but we'll get to that. What I'm going to do is I'm going to take this out, clean it really well. What I want to do is get this bottom board out so I can inspect it. There's probably cracked solders on here that we're not aware of yet. At this vintage, this age, it's got the green TK caps, and those, in my opinion, are garbage, so they all come out. So I'll probably end up doing a recap on this. Volume control, you can see that it's all open and exposed, so there's a lot of dust and dirt in there that'll need cleaning. And then all the function switches and whatnot are down on that board. So I think it's just a matter of taking it apart and attacking it one piece at a time. So I'll take the front off, and I'll remove the phono stage, probably the back panel, connectors, tuner, all that stuff will come out, and we'll deal with those separately. So yeah, I blew out all the dust. That was a good thing too, because it was pretty nasty in here. There was dead bugs and hair and all kinds of unknown stuff. So I got rid of that. And the more I look at this, the more I look past the filth, the more I like it. It's got good bones for a project here. I think what I'm going to do is clean this thing up. It's pretty dirty. If I clean it up, at least I can sell it. If I don't clean it, I don't want to sell it to somebody having it filthy like this inside. So I might just take the steps of the extra steps of removing some of these boards and putting them in the ultrasonic and cleaning this thing up and making it shine again, as well as sound good. So I think I'm going to take it that way. So I'm just going to take the back panel off and take the tuner out, take the phono stage out, and like I said, a few other things, and just get busy on this. Yeah, looks like it might be a nice project. Easy one too. Alright, this one here on the right is our balance pot, and I don't see any cracked solders on the back side here. Looks pretty good, but I'm going to remove it and see if it responds to a cleaning. If it doesn't respond to a cleaning, we're going to have to replace it, but don't know if I can find one like this. It's a dual pot. Let's try removing this. I don't see it damaged in any way. Yeah, might be tricky, this one. All right. Okay, we got those 4 cleaned off, but these other 2 are folded, so I'm just gonna give it some heat and pull it out. Pull this one out. Clean that. Let me connect up. I don't know which one it is. One of them's working, one isn't, so let's get a resistance reading here. Okay, 2.5 megohms. I guess that's the bad one. And this is really, yeah, 65K. It's supposed to be a 50K pot. 30K. 15K. Yeah, it's all over the place. Let's try this one. $41. This one's adjustable. It goes down to 2 ohms in the center, and then it stays low all the way through the other wipe. So yeah, it is that one side is bad. I'm going to give it a treatment with, let's see what we can treat it with. 401B. Okay, this is 401B, and this has the lubricant in it. So let's see what we can do with this. It's the back one too, and if I can take the back one off. See, there's 4 crimps there. If it doesn't respond, we're going to go brute force method. Let's try it again with the ohm meter. Okay, 40. It is really jumpy. 42K in the center, which it shouldn't be. It's not even making contact here. Goes down. Oh, it's really messed up. Let's open this thing. the spraying stuff in it isn't going to fix it. We have to do some serious cleaning here. Okay. All right. Let's get some cleaner. Now it could be the center ring that is really oxidized. I don't know if you can see this here. See, the center ring is oxidized, and then the outside ring is your wipe. Two sets of contacts, one on the outside, one on the inside. And yeah, we'll get this working good. It's just a matter of cleaning it up. Okay, let's give it some of this. Wondering. I want to clean this center ring up because that's silver plated and it is all black. What can I use? What can I use? Let me try another cleaner. Okay, so I'm going to try this stuff. Now I don't want to get it on the carbon track. I want to just use it on the center ring. So I'm just going to put some on a Q-tip here. Oh, my can's empty. Let's see here. Okay. Not too much. I just want to clean the center. I have a feeling the oxidation on this center, like it's probably copper with a silver plate, and once it oxidizes, it breaks the connection. Not really taking anything off either, but it is coming cleaner. Let's give it a little scrub. Okay, what I'm going to do, I'm going to treat it with this F100, and I'm just going to give it a small amount on the track here. Let me inspect this track first. I don't see it damaged anything. So let's treat this. Let's put it back together. Okay. Okay. Work it, baby. Let's treat the other side too while we're here. Okay, let's test it one more time. If it fails this, we're going to have to replace it. Find a replacement. Okay. So we're at 43K right now, and we're at one end. Come down. Nothing. Okay, we're at... Okay, I'm doing it opposite here. It's working, but it's not... One track will be opposite the other track. Okay, we're at 43K, come down to center, and we got 3 ohms, and then throughout the center to the other side, it's working now. Here, I'll show you. Okay, there's fully clockwise, 43K. Come on. 43K. If I turn it down towards center, 9, 10K down to center. That's center, 3 ohms. If I wrote from center to fully counterclockwise, it goes 10, 12 ohms. And we're turning it slowly, 7, 8. It's staying low, which it's supposed to. And at the end it's 3 ohms. So it's working now. It doesn't seem to have any holes in the range. I'll test the other side too. But I think this can go back in. I think it's going to work. Okay, that worked. I'm happy about that. So I put this button back in. Let's see here. Will it fit? Yeah, it will. Now I'm probably going to remove the other 3. This is the volume pot, and this is the bass treble. And I'll do the same treatment for both of those. I won't open them up, but I'll give them a good cleaning. And these ones don't seem problematic. They seem to be working okay. They're just a little scratchy. So we're going to give a good cleaning with the 401B, and then we'll follow up with the F100, and that'll put them on track for being good. And then this switch here, this switch is the loudness. It didn't seem, I didn't see this switch is the loudness, and I didn't hear it working when I tested the amplifier the other day. I was playing with the loudness switch. It didn't make any change. So either it's really gummed up or we have another problem. So I'll clean that one as well. In case you're wondering what's the difference between a regular pot and a balance pot, let's draw a regular pot here. We have our 3 connections. Got our wiper. You got your 2 resistive element connections, and then you have your wiper. So let's say this is a 50K pot. So you're going to measure 50K between here and here. And then this is continuously variable. You can go either direction and adjust this to be like 20K or in 30K, or split the difference, 25, 25, whatever. This is what they use in for regular potentiometers like bass treble controls and the volume control. All they do is they add 2 of them together, and the wiper are mechanically connected together between the 2 of them, and they track together, right? But for a balance pot, it's different. You have 2 potentiometers, 1 for each channel, and you have your wiper is, so you have separate, they're completely separate from each other because you have 1 for each channel. And on one side you have a resistive element here and then nothing, and then on this one you'll have a resistive element here and then nothing. And these 2 are tied together, so they track together. So you'll have 50K between here and the 12 o'clock position, and here you'll have 0 ohms between the 12 o'clock position and that side, and then here you'll have 50K here and here, and then here you'll have 0 ohms again. And that's the difference between a regular potentiometer and a balance pot. So when you have it in the 12 o'clock position, you have pretty much a 0 ohm connection for both channels, and you have no attenuation. But when you start turning your knob and it swings one way or the other, then you start getting into this resistive element, and what happens is you can attenuate your signal from full or 100% down to 0%, right? And then between here and here it stays at 100%. That's how that works for this channel, and then it's opposite for this channel. So yeah, that's basically how it is. Alright, let's look at the speaker connector, because this has got some problems. This one here is broken completely, and I don't know if you can see that it doesn't even close inside, no matter what position it's in. So, if that was the only problem with this, we could easily just rewire this and put the connector in upside down. We could use this as our A system, this is our B, and never use the B. But this thing has more problems than it appears. This one here is broken as well. I don't know if you can see it. There's a little tang, 2 tangs missing off each end. This one's cracked here, broken, and this black one's cracked here, broken. And I think that's it. But this connector is done. So I'm just going to, what I've done is I made a little diagram of which color wire goes to which speaker connector. And I am going to use this as my guide for my new one. I'm just going to remove all this because it's all trash. Let's just remove all of these wires. And we'll have to figure out another solution. Now, I looked at using banana posts, binding posts. There just isn't enough room unless I start hacking at the back cover. And I really don't want to make any changes to the back cover. I just want to make something that just drops in and looks OEM and works, you know. So I have a good solution here, I think. Let's get this off. And our 2 ground wires. Okay. Yeah, this is garbage. So what am I going to do? Let's see here. There's our back panel, and I got these. These I bought at DigiKey. They are not audiophile quality. They're not the greatest thing, but they're good in a pinch. So what I plan to do is put 2 of these. These fit just perfectly inside this opening. I'm going to put one here like this, if it'll allow me. Right, and then I'll put another one facing downward. But I have a problem. We have to cut some plastic to get these 2 to fit. We have probably cut about 6 millimeters. Well, we'll see, probably have to cut 2 or 3 millimeters off each one to get them to sit closer together so that they both nestle in there. But I think this is going to work. So I'm going to work on cutting this, and then I'll bring you back and I'll show you what it looks like. Okay, what I did is I cut off about 2 or 3 millimeters with a pair of tin snips. This cuts the stuff pretty slick. So I cut it off, and then I just trimmed it up with a razor knife just to clean it up a little bit, just to smooth off the bumps and give it a little more straight of an edge. You can take a file to that too and clean it up. Did both of these, but now they fit just right. It was like it was made for this. So if I put this one in here, this one in here, you see how they look. And if they go completely down onto the steel, and looks completely factory. So what I need to do now is drill the plastic out on this hole and this hole, to bring it through. And I want to get like a steel backing plate, kind of a strut that sits behind here that I can use it to clamp this down to the back panel. So I'll have to cut a piece, probably 12 millimeters wide by about 40 millimeters long, and it'll be like maybe 2 or 3 millimeters thick. A chunk of steel. I'll just go in the garage and cut up a chunk of scrap and I'll drill a hole in it, and then we can use that to clamp these down and call her a day. I think that looks pretty good. I don't know. I'm sure it'd be good enough for some people, but okay, so I finished all the capacitor replacing, and just a few notes here. The original filter capacitors tested just great. They're 6800 microfarad at 45 volts, and they both tested over 6,000 microfarad. So I opted just to put them back in and leave them alone. They're already at a point. They're already at 6,000 microfarad, and they're holding up. I think they'll be fine just to keep them going. All the rest of the capacitors have changed out. Came as kind of a bit of a surprise. I started on the phono board here and replacing caps, and I was pulling out caps and they're testing perfectly fine, and I was like, well, maybe I'm wasting my time here. And then I got to the main board and I started pulling out caps, and a lot of them were cooked. Actually, no, they weren't cooked. They were just failed. They just failed from age and poor quality. And then I really saw it when I got to the tuner. Really saw a lot of bad capacitors in the tuner section. Yeah, well, not all of them, but the majority of them were bad. About half of them, I'd say. So, what is going on with these capacitors? Well, let me show you. So these are the ones I tested and they're fine. They probably could be still used. And these ones I tested, these ones have all failed. By what I mean by failed is they're down to either half their value, or some of these smaller ones. There's like 1 microfarads in here that tests way over their value. So a shocking 41% of these capacitors failed in this receiver, which reinforces my belief that, you know, a receiver of this age just must get recapped. Must. It's not an option at this point when you have this percentage of capacitors fail, and you're still working on these ones. There's no two ways around it. If you have one of these receivers, they're going to need new caps. So, and I went through and made a list. Throw those away. Made a list on my cap replacement list, and if I do decide to make a cap kit for this receiver, this will be what I'm using. And yeah, it's necessary. Let's throw these away. Throw all of these away, even though some of them still are testing okay. Okay, that's out of the way. Power amplifier, nothing really to talk about. Everything went well. Clean up the back of the board, and I think it's pretty good now. I touched up a lot of solder joints. A lot of them are starting to crack, like these ones, these clusters around the driver transistors, they were starting to crack. So I touched all those ones up. And this can go back in. Okay. Phono board and input switching. Not much to talk about here either. Same kind of thing. A little bit of crack solders. I didn't do anything with these two switches because they are pretty much sealed, and I don't want to take them apart, and they weren't presenting any problems, so I'm just going to leave them alone. Capacitors, all audio grade except for where there's power. I'm starting to try out some of these solid polymer caps, and I'm going to try some of these in future projects. Kind of liking that. I'm getting them. I can find them at a good price, and if I can get them at a good price, I'll start using them. But if they're expensive, they're going to have to. Okay, tone board and volume control. This switch here presented big problems. Tested the contact resistance, and it was in the like 200 ohm range, which wasn't good enough. I had to take the switch apart and clean it, which resulted in me effing up one of the leaves inside, and I had to straighten it out and put it. These are difficult switches to clean manually. You have to disassemble them, and they're not fun. I looked for a replacement, but I don't have any that would replace this. The tone board itself, there was only 6 caps here. 4 of them are now film caps. The other 2 are audio grade. Cleaned the potentiometers, the balance pot. You remember that? We took that apart and dealt with it. The tuner. This is where we had most of the dead caps. I'm surprised the tuner was even working, considering how the capacitors were. Still have to clean the back. I haven't done that yet. And I'll get on that next. The lamps. I'm going to take these 2 incandescent lamps out and replace them with LEDs. We'll get to that. Here's the back panel, finished. Got it connectors in and bolted in. Got them couple of steel bars to clamp them in. I'm not happy I didn't paint them, but well, whatever. Looks a little bush league, but this will work great. And yeah, it'll look factory OEM. So now I just need to clean that back, the tuner board, and then start assembly. Alright, we're back together. One thing I want to do is I want to change these incandescent bulbs from filament incandescent to LEDs. These bulbs are notorious for burning out on these VXI series receivers. So I'm just going to pull this out. if it'll let me. Okay. There's a little plastic rivet you have to release. And then you got your two bulbs. These ones are working, but I don't think they're going to work too much longer. They're pretty tired looking. Put two LEDs in. We have some space here. Put a dropping resistor. We don't need to use that space, but we can. This was originally fed with 16 volts AC directly from the power transformer. And then it went, power goes in here in these two green wires and came out here on this you can't even read it. But that's where the lamp power came off, right here. So what I did is I took that wire and I moved it over to the main filter cap, and I'm taking DC off the main filter cap instead of AC off where the fuse is. So let's measure the voltage here before so I know exactly how much power we got. Let's shut this off. Plug this in. Let's see if it blows up. First power up. Looks good. Okay, we need to measure the voltage here. First, let's measure the AC voltage. AC voltage is 16.4. Okay. AC voltage will be that a little bit higher. Don't want to short it out, so I'll pop the fuse. So we got 20.2. Alright, so that's good enough to work with. What I'm going to do is I'm going to do the calculations and see what kind of dropping resistor I need. I think I'm going to use these LEDs. These are cold white. This LCD has a green filter on it. I thought I could use high brightness green LED, but I don't have any. I thought I bought some, but I don't have any here. So I'm going to try this. These are a cold white. I'm going to see if they're bright enough at about 10 milliamps. I'm guessing 10 milliamps to start, just to see how it runs and how bright it is. Okay, I took out the two bulbs and I replaced them with LEDs. And I also removed the resistors. We won't be using those. Now what we got here is a parallel circuit of two LEDs, and then we have a break here that we can put our limiting resistor. Now I did the calculations for 20 milliamps for a white LED on 20.2 volts. We're going to need about 850 ohms of dropping resistance here. But they don't make an 850 ohm resistor. They make an 820 and a 910. So I'm going with the 910. Here is a 910. I'm going to use the 910 as my dropping resistor. Now, you're probably wondering, why did I choose 20 milliamps? Well, these two LEDs are in parallel, and I'm assuming around 10 milliamps each. So that's why I calculated for 20 milliamps. So I'm going to take this chip resistor and mount it, if it'll cooperate. Let's see if I can do this. Zoom in. Okay, I got a little chip resistor there. Just have to get it in position. Hold it down. Tack one side. Okay. Now it's held there. Take the solder and I can solder the other side. And then we can solder this side. Pretty easy to use these chip resistors. I like them. So there's our dropping resistor, 910 ohms. And this is the positive down the bottom here. So let's take our wires. take our wires and install this. Let's solder one at a time here. I could have just as easily used a regular resistor. I guess I had the holes for it already. I put it in there, but I like using chip resistors. It makes it cleaner end result. Okay. All right. We are connected. So let's power it up. Here's our LEDs. Let's measure our voltage drop. See if we can do this. .1. Let's check our current. I equals E over R. E over R. Did that wrong, didn't I? So we're at about 18 milliamps. 18 milliamps times 17.1. So we're at about a third of a watt dissipation here for this little resistor. Yeah, I can feel it's warm. Third of a watt is no problem for this. It's, you know, it radiates, the heat radiates along with the copper. So that's going to be okay. Let's see how it looks with our shroud. See, not bad. Don't know how well you can see that. Comes through pretty good on the camera. Looks pretty good in real life. Doesn't have any weird color to it. It's all green. I think I'll just leave that like that. I was thinking maybe put a diffuser lens. I don't think it's necessary. I don't think it needs diffusing. Stereo tuned active tracking. Okay, it's time for everybody's favorite segment, bias adjustment. So let's do this. It's been on for about 5 minutes. It's been powered on for 5 minutes. I'm just going to put the meter here and you can't see. There we go. So we're measuring across both emitter resistors. The manual states test point 1, 2, 3, and 4. Test points are the 2 pins on this emitter resistor that are together. So that's your opposite ends of the 2 resistors. And we're measuring from one emitter to the other emitter on the transistor. So connected here on these 2 posts and these 2 posts for that channel. And I was looking down here. There is the tuner bracket is in the way for this one trim pot. So if you use a metal screwdriver, you're going to short this out to ground. So you need to have an insulated trim screwdriver. I'm going to dig out my ceramic one here, and we'll use that today. So let's connect it up and see what we get here. Now the spec is 40 millivolts across both resistors, or 20 millivolts across one. We're on the millivolt scale. Yep. And we're at 43, so we're a little bit high. Turn this one down. What is our consumption here? The consumption is 32.25 watts. Let's turn this one down a little bit so you can get in here. If I can. Whoa, just such a small amount. Okay, 40. We want 40. Going backwards. It's a little twitchy. Probably could use a cleaning. Okay, we'll leave it right there. Let's do the other channel. This one's low. Okay. What? We have no adjustment. .4. The wattage is going up and down, but the adjustment is not changing. Okay, maybe I didn't have a good connection. There we go. What is going on here? Okay. That was weird. Okay, let's turn this up. Turn it a little bit on the low side. It says plus or minus 2 millivolts. But yeah, that was weird. I don't know why the meter wasn't picking that up. This meter was picking up the increase in current, and the wattage went up as the current went up, but this one stayed flatline. That was really strange. So I'll let this cook for about, they say half an hour. I'll let it cook for half an hour, and we'll come back and we'll tweak this one more time. Yeah, we're a little bit high on this one. Turn it down some more. Going the wrong way. Oops. There. So we're at 30 watts consumption. It's about right. Slightly warm. We'll let this sit for a while. Okay, so this knob, it looks like it's been glued. I don't even see there's, and you probably can't see it. Looks like somebody used either epoxy or super glue to glue this. It probably came apart. What they did is they glued it, but it also looks like somebody tried jamming this knob on the D shaft the wrong way. It wasn't keyed right when they tried pushing it, and they damaged this part right here. It's all messed up inside. I don't know if you can see that. There is chunks of plastic missing inside here on the D. So this is all rounded out here, and then this is spread apart like it's been split. So like somebody put it on and jammed it, and then they figured out, oops. So if I put it on, the shaft is not bent. Okay, I checked that. You can spin it around. If I spin it, well, you can't do this so that you can see it. The shaft's not bent. Okay, it's pretty good. The problem is the plastic here. So you put it on, you push it home, it's loose for one thing. Plus it has a little bit of wiggle. It has that wiggle, which is play in this. So what I think I'm going to do is I'm going to try doctoring this up with some UV epoxy. See how it's loose. Even if it's pushed on, it's still loose. If I push it all the way on. Oh, hang on. No, that's too much. But it still has that bent look to it. Wow. It's just scraping the plastic apart. Try that again. Push it home. I don't want it to go so far. Yeah, let's do that. Let's fix this knob up. I don't know if you can see that, how it's messed up inside where the shaft goes. The plastic's all. Now I got a new pot here with the D shaft on it. Let's get this open. I'm just going to use this as a fixture or a jig. What is this? 1K. 1K pot. Okay, so this fits here, or does it? You see it's got a little bit of a... You can see how this is spreading and not holding the shaft. I don't know if this is the same size as the receiver. It doesn't look like it. It looks like it might be bigger, which might be a problem. So if I push this on, yeah, it splits back here. You can see how wobbly it is. If I push it this way, makes it worse. Push it this way, it's better. Okay, what would work is if I wrap this with a fiber. I've done that before. I'd wrap the collar in epoxy and fiber, and that would clamp this back together, and it would secure it. It's going to be really difficult to wrap that. Oh boy. But the back end here is spreading, which is, I think it's cracked. I think there's a crack here, right here at this reinforcement, and then right, this one I don't think is cracked, but this one is. And I think it's also cracked maybe up here. It is, yeah, there's a crack on the inside. That's why it's spreading out. And this shaft is bigger than the maybe if I find the proper size shaft, I can do the epoxy trip. Okay, I found this one. This one's more the correct size. See how loose it is? It fits in. So I think what I need to do is reinforce this so it's straight. I want it to be straight. And then we'll epoxy it. See how much play is in the shaft there? That's the part of the problem. Okay, let's do this. So, first step, we're going to smear some grease on this. Not very much, just a touch, just to keep the epoxy from bonding to it. You don't want the epoxy bonding to the shaft when I stick it in here. So, you can't go too far either. And we have to straighten it. So we have to put a little bit of pressure here to straighten this out. So what I'm going to do is I'm going to get a little piece of wood. What I got is a wooden toothpick, and I'm going to use it as a strut between here and let's measure this correctly so we don't have to do it twice. Between here, yeah, see, this might be a problem. Probably right here. I'll cut this. You can use that as a strut to push on this. Maybe it's too long. I think it's good. Oops, it fell apart. A little bit too long. There we go. Okay. I think we're good. So I'm going to start epoxying right here. I'm going to dribble down into this crack. Come on, baby. You see this? And let it flow down inside. Let's cure this. I think it's straight. Okay, I'll finish curing that after. Let's get this side. So let's dribble some down on this side too. Give it a chance to flow. Okay. All right, I'm going to set this up with the UV light, and then okay, I think we're set. So if everything works correctly, I should be able to pull this out. And the grease did not stick, but I have. Let me get a little bit more, need a bit more UV light in here just to make sure the inside is cured. Okay, just going to clip this off. All right, let's try it out. Straight. Look at that. So, what am I going to do? I'm going to put some more around here just to keep it from breaking out. And I don't know, I might wrap it, I'm not sure. But we have the we have it so that it's set. Or is it breaking loose? I can't really see. I think this will work. Yeah, I'll clean this up. I'll give it another layer around the outside. Maybe put a wrap or two of fiber around it too, just to keep it from spreading. Okay, I got it wrapped with about 4 wraps. Just enough to build some strength around the outside so it can't expand. And I got it taped down. This is the stuff I'm using. It's just fishing line, spider wire. 50-pound test. I don't know, found it at Walmart. So, I'm just going to put some of this around the outside of it. And then we'll harden this with the light. Put some around the outside here. Don't want it flowing inside. I'll just harden this. Give it some more on this side. We've got to preserve our D inside. We don't want to get anything inside there. So let's harden this. And this is just some UV LEDs I put together. Just for fast curing. Okay, I think we've got all angles covered. I can probably snip these off now. I need a knife. Okay. finish curing this, and then we're going to call her quits. Alright, we're ready to do a power test. Have my usual 1000 hertz tone, and I have the 8 ohm load connected up. Watt meter, voltmeter, everything's ready to go. So let's turn this on. And we're on speaker 1. Okay, amplifiers are up. Everything should be on CD. Let's see. Silent, because that's shut off. Yeah, because we have no speakers, that's why I can't hear anything. Alright, so let's turn this off. Looking good. Okay, take this up. There's clipping. Back it off a little. Right there. And we're going to start the timer. Let's see how this goes. So right now we're consuming 184 watts, and our output is 19.45 volts RMS. Actually, I readjusted it and it's 18.7 volts RMS. It's a cleaner sine wave. I had it a little too high. Okay, we're coming up to the 6-minute mark, and I'm starting to get to the point where I can't hold my hand on the heatsink anymore. So it is running a little hot. So they could have done better with the heat sinking. They could have made it about an inch taller. I think we have, yeah, there's easily an inch. They should have made it an inch taller, give it that extra mass and surface area. But they have to cut costs. So I'm going to shut this down at 6 minutes. Although it worked flawlessly. Let's get rid of this. Now, well, let's see how it looks on the square wave. Okay. There's a 1000 hertz tone. It looks really good. It looks really good. Looks like something you'd see out of a computer. Okay. Let's go up in frequency. Let's see how it goes. So this thing was rated at 34 watts. And what did we get out of it? We got 18.7, 18.4. So yeah, this thing was rated for 34 watts and we're getting over 42 out of it. It's pretty good. Let's have a look at this frequency here. What are we at now? We're at 1 kilohertz. Okay. Let's do this right. Okay. 3, 4, 5, 6, 7, 8, 9, 10. 10 kilohertz. Still going strong. There's 20 kilohertz. Looking good. Still looks good. Starting to show its limits. Let's go up until we can't see a square wave anymore. I'm guessing right around here somewhere. 63 kilohertz. Pretty good. back to 1,000. Okay, so I did my initial testing. FM tuner works great. AM I didn't test. I don't have an antenna on it. I think it's working fine as well. I don't see any reason why it wouldn't. But we did have a problem on the phono stage. We only had one channel coming through. And yeah, so I was going to do a video on, or do a segment on feeding a signal in and testing with a scope to see where I lose it. I thought maybe the switch was bad, but I don't know. But I just started connecting things up to do testing, and look what I found here. Look at this. We have a broken wire here. So I got to remove this board and re-terminate this connection here. This is just from flexing and you know, this broken wire. So that's what you get. Oh, they're both broken now. Both channels are out. Let's just break it. There we go. Okay, here's my cable down here. Got it stripped, and I got the old holes cleaned out. So let's get this back together. Okay. That's the problem when you're working on these things, wires get broken. If you're not careful when you reassemble it, you get something that's buried and you can't see, and then you don't know you have a broken wire somewhere on a board, and that's the cause of your fault. So you spend hours trying to track it down. Yeah, so that's the fun of all this. So that's back together. Okay, we can put this back in, and I'll button that up and we'll give it another test. Okay, let's test it one last time. Turn it on. See what we get out of this. So we're on FM right now. Left, right. Okay, phono. Left, right. Okay, we got both channels. I'm feeding a 10 millivolt signal in, and it's there. It's coming through now, so it's working. I'm going to wrap this up. I'm going to button this one up and close this up. I'm going to try listening to it for a few weeks. I think this is going to sound good. If anything, my 550 VXI is anything to go by, this thing will sound good too. So I'm going to have a little bit of one-on-one time with this and listen to it. This one I'm probably going to sell. I probably need some funds to help me pay my heat bills this winter, so I'm going to try selling this and get my money back out of it. But there it is, it's done, and I'm kind of pleased with the results. Even though it's not a high-end receiver, it's a good performer. You saw in the square wave tests how good it looks on the scope. So yeah, I'm going to be excited to listen to this one for a while. So take care, and we'll see you in the next one, and hope you're all well. Talk to you later.